Hello everyone. So in this particular video, I am actually trying to come up with a solution to a problem, which is basically a recommender system, and I'm just putting this as an idea in front of you guys. And what is the expectation is that I hope some people take an interest and then give their feedbacks, because we are actually trying to build this into a system. Definitely not something very formal or very let's say very important or something, or we are not going to make a product out of it. However, it is definitely something that I want you to ponder upon and think and come up with solutions, basically, okay, so that we can let's say create some system of ourselves, that's going to help us understand recommender systems in more detail. Okay, so here's the idea. Okay, this is the thing that I have been thinking, and please add to this. So let's say you are a person, obviously, and in this recommender system, what I want to do is to assign a vector. Okay, let's say this is an m-dimensional vector. Okay, now the difference that I am creating over here is this is a learnable vector. It's a learnable vector, or let's say learnable weights. Okay, but weights is m cross 1. The idea is we are going to give this to a neural network. Let's say neural network 1. Okay, n1, let's call it n1. Okay, and I'm going to just name it as people network. Okay, people network. And obviously this is a neural network, so let's say the input dimensions, so there are m neurons over here, and we have n neurons over here, so we will be getting a n cross 1 vector. So this is also going to be a vector. Okay, now what I want to do is, so this is the output vector for every person, right? Let's do it for something else. Let's say we are trying to build a e-commerce recommender system. Okay, something like Amazon. So this is a product. Okay, this is the person, and it's a product over here. Okay, it's some product. What I am saying is I am also going to represent this, let's say, in m dimensional. Okay, so these are same. Okay, so this is also m dimensional vector, and for that we are going to have a different neural network. Okay, over here let's call it n2, and it is also going to take a m dimensional vector m cross 1 and spit out a n cross 1 dimensional vector, just as above. But remember, these two are different networks. So this is a product network. Okay, product network. So since you have a n cross 1 vector over here, and you also have a n cross 1 vector over here, the idea is to take these two vector. Let's say you are a person and you bought this product. It means that there is some similarity, or let's say you as a person, you as a user, and this as a product had some association, not maybe not similarity in that particular sense, but some association that needs to be captured by m cross 1 vector and this neural network. Okay, so this is the entire idea. So how we're going to do that, and what is going to be our loss function? So basically you have a n cross 1 vector over here, n cross 1 vector over here, and I am going to compute let's say cosine distance. Why? Because we need I'm sorry, cosine distance. Why cosine distance? Is because we need some kind of a loss function, because it is this loss function that we will try to minimize. So what will happen is, obviously there will be some distance that will be found, and the idea of reducing the distance is that in certain space, okay, so this m space, and due to this neural network, these weights are going to be changed, because these weights and this new this vector, even these two vectors are learnable weights. Okay, and these are going to represent person and product. Okay, these are totally different. So in this space they are supposed to be closer, because we are going to reduce cosine distance and then back propagate this error back to this vector. Not only the network, obviously the network will also get trained. Why? Because we are back propagating through the network, and we will also be updating the weights. Now my question to you is, do you think these kind of a system works? Or instead of cosine distance, what I also thought of using something as a contrastive learning. Okay, so if you don't know, you can read about it. I know I have not uploaded a video on this. There are so many things that I need to do, but what my basic goal is to basically try to get some ideas for some people who already know. Yes, I teach deep learning on this channel, but it will be a good exercise even for you to actually ponder and think upon this particular question, and then brainstorm, and let's have a discussion over it. So What do you think about the idea, or what are the things we can change? What is the good thing about the idea is, basically, number one, we are using representation, that is a vector of even a product, of products and people of the same dimension, that is m cross 1 m cross 1, which means these weights will represent something about the person. What does it represent? Generally we say neural networks are black boxes, which means we don't know, we cannot interpret it. But since it works and we are able to prove that, it means there is some knowledge to it. Now how we are able to, how we will be using it? Obviously when we are done with this, we will take an unknown product. Person is going to remain the same because we are going to recommend it for the person. We will take an unknown product. Let's say this was product 1. We will take unknown product. Let's say this is product, let's say this is product 2. Okay. And then what we are going to do, this is also associated with a vector because it has been trained with some other people as well. And then we will pass this to this particular neural network, and then pass this also to the particular neural network. It will give some output over here, and this will also give some output over here. And then we will again find the cosine distance. If now this is during the inference time, which means there is not going to be back propagation. Okay, we will see whether the cosine distance is small or not. This is a product that this person has never bought, but since we are using these neural networks, we should be able to figure out what is the cosine distance after passing these two, this particular product and this particular person, and finding the cosine distance over here, and then using it as a recommendation if the cosine distance is less. Okay, so that's the idea. Now so that's number one, representation, learnable representation of both people and learnable. I know my handwriting is not that good. Learnable representation. So I'll try to be a little better over here. Learnable representation of person and plus product. So that is one thing that we are doing. Now I'm not saying this has never been tried out. I have read papers that similar things have been tried out, but I'm not copying anybody, obviously. And second thing that I thought is, why should I initialize this and this, and in fact this and this randomly? I'm not going to initialize this randomly. Obviously, there are datasets that can be used, but I thought there are already methods like collaborative filtering and content-based filtering. I am somehow, I don't know how, but I am going to somehow use that knowledge to initialize the weights of these, let's say, vectors and these neural networks in such a way that my learning curve, or let's say the learning curve of these networks, is not going to be that steep. Okay, so obviously there is some information, not a lot, but it's already there, hoping which we will, and what is the hope? We will generalize, or the loss is going to reduce quickly. So these are the two things we are trying. Obviously there could be a third thing and a fourth thing which I want you to brainstorm and give me ideas, and in that process we both will learn and we both will help each other. So I hope you like the video. If you like the video, please like and subscribe. Thank you very much, and bye.